Good afternoon, guys. Welcome back into my channel. So in this lecture and lab, we're going to talk about, let's go ahead and double check it here. We're going to talk about IPACLs to mitigate attack. And at the end of this lecture, we're going to configure an IPACL to mitigate attack. Again, this is the CCNP/CCIE book from Cisco. So it's CCNP and CCIE Enterprise Core and Encor 350-41 official set guide. So, so, oh, come. So, so, um, so then we have this book just for knowledge purposes. If you wanna, you know, if you wanna, having a copy of this book, I'm gonna leave a link in the bottom of the description on each video, so you can click there and have this book. So if you see here, you will see it says controlling access to VTY lines using transport input. So another way to further control what type of protocol are allowed to access the VTY lines is to use the common transport input all non-telnet SSH underline configuration mode. So we have all the keywords here and the description. So all allows telnet and SSH. None is blocked telnet and SSH. Telnet allows a telnet only. SSH allows SSH only, and telnet SSH allows telnet and SSH. So this is a very good um example description table. So it shows different, transport input all, transport input one, transport input telnet, and transport input SSH, transport input telnet and SSH. So the console port CTY line should be provisioned with the transport input none. Command to block reverse telnet into the console port. So verify access to VTY line using transport input. So again, you will have this book for free. So I would encourage you or recommend that you have this book so you would, you know, be able to read, browse into it. And this is a PDF book, so it's very flexible. You don't have to have it as hard copy. I know some people prefer the whole, method way, but um, having this PDF version, it's undestroyable. You could access it to any computer you'd like. So enable SSH and PTY access. So Telnet is the most popular yet most insecure protocol to use to access the iOS devices for administrative purposes. So Telnet session packets are sent in plain text, and this makes it very easy to sniff and capture session information. A more reliable and secure method for device administration is to use the secure SSH protocol. So SSH which provides secure encryption and strong authentication is available in two versions. So SSH version 1. This is an improvement over using plain text telnet, but some fundamental flaws existing in its implementation, so it should be avoided in favor of SSH version 2. So SSH version 2 is a complete rework and stronger version of SSH that is not compatible with SSH version 1. So version 2 has many benefits and closes a security hole that is found in SSH 1. So SSH version 2 is certified under National Institute of Standard and Technology, NIST. So this is very important, especially if you want to go to the route especially if you want to go to the route of Cisco security or cyber security, whatever it is. So a federal information processing standard, so pipes, so again, and so it says 140-1 and 140-2 US cryptographic standard and should be used where feasible. So the steps needed to configure SSH on an iOS devices are as follow. So you have them here. There we go. So guys, I would go ahead and jump on the little lecture that I prepare here, especially for that kind of configuration. So threat mitigation with ACL. So since the lab configuration is with configure IP ACLs to mitigate attacks, so I prepare a word lecture that speaks about threat mitigation with ACL. So ACL, which is access control list, or a fundamental security mechanism that used to guard against cyber attacks in modern networks. This article examines the different type of access control list that you can use right away in order to help harden your network. So in networks today, one of the most important issues that we must deal with is security. Specifically, we need to make certain that our devices are hardened against the threat of a cyber attack. So cyber attacks can take many forms. However, the majority of the method used to reduce our exposure to these threats rely on or utilize a very basic networking tool. So we are talking about access control list, which is ACLs, whether they are applied directly to a router or a switch interface or use a part of a zone-based firewall configuration. They quickly become one of our first lines of defense against the external and internal threats. So as CCNA security, just if you want to do CCNA security, this topic is for you also. So CCNA security candidates, so we need to understand that our network security depends strongly on well-written, organized, and concise ACL to restrict access to network devices. We are going to take a critical look at different types of ACL, specifically how they can be identified and applied. So what are the basic type of ACL in iOS? So we have them here. We're going over them. So in case if this is the first time you're watching this video, I would recommend that you watching the previous videos so that you may know what are the different type of ACL and how do they configure. So they're following source IP addresses, destination IP address, source TCP and UDP ports and destination TCP and UDP ports and stuff like that. So these things we already talked about them on previous video. So shortly we will take a close look at the ACL type individual, but what we need to understand now is that the extended ACL, as their names implies, offers us much more flexibility than to standard. So we already ran over that already. So there's no need to even stay on this. Now this is an example of how to configure ACLs and stuff like that. So denying access and bang. So just to avoid a longer waiting, just to make this video as short as possible, where do we apply ACL? So standard ACL, bang. I already went over that. So standard ACLs only match the source address of a packet. It is more effective to apply them to close to the destination of a packet. So I already went over that on previous videos. So like I said again, I would recommend you to go on our previous videos and take advantage of what we have, what we had offered. So now let's pull up packet tracers. So what we're going to do today is to configure IP ACLs to mitigate attacks. So the addressing table gives us all the devices here. We have 3 routers and 2 PCs, PCA and PCB. And these are the NFS. That's the IP address, that the subnet mask and the default gateway and the switch port. So the objective says that verify activity between devices before ACL configuration. Use ACL to ensure remote access to the router is available only for management station PCC. And it says to verify ACL on router 1 and 3 to mitigate attacks. Verify ACL functionality. So now the background scenario says access to the router 1, 2, and 3 and should only be permitted from PCC, which is the management station. So PCC is also used for connectivity testing to PCA, which is a server that provides DNS, MTP, FTP, and HTTPS services. So you will apply ACL on the edge router to mitigate common threats based on source and destination IP address. In this activity, you will create an ACL on the edge of the router 1 and 3 to achieve this goal. You will then verify ACL functionality from internal and external hosts. So the router have been pre-configured with the following. So let's go ahead and copy this so we can get inside of the routers. So from router 1, by the way, so let's see, it says verify basic connectivity. So verify the connectivity, verify network connectivity prior to the configuration, the IPACL. So from PCA. So from PCA, sorry guys, just give me 1 second. So here it says from PCA, verify connectivity to PCC and router 2. So from the command prompt ping PCC, so from PCA, it asks to ping PCC. So let's go ahead, command, and PCC IP address is this IP. So let's grab it. Let's say ping and paste this. And then, so it's access to ping PCC. So from, yep, so we good. We got a success ping. So it says that from the command prompt establish. So it says verify connectivity. So from PCA, so we have to ping the router 2 as well. So there go router 2. This router 2 IP address. Oh, this IP here, I would assume. Oh, there we go. So from router, it says to ping router 2 interfaces 2 as well. So we got to do that. Let's just do an up arrow and remove these, and then paste this IP. Okay, so we gotta. So that's for that's just for one serial interface. So we gotta try the other ones too as well. So as we've been told, okay. So hit ping, and then paste this. So we good. Now we have a last IP that we have a loop back address in that IP. Okay. Now let's try this. Gotta hit ping, then paste this. So it asks us to verify the connectivity, and that's what we're doing here. So we have a loopback 0 address, which is the last one, last ping that we gotta do here for this part. Okay, ping. Oh, sorry. There's a typo here, so it's ping, not PIG, PING. Oh, sorry. Go ahead. So it's ping. Okay. So now we've done with this part. It says on step 1, it says that we have to do this ping here. So it says from the command prompt establish an SSH session to router 2 on loopback 0 interfaces. Okay, so we have to do an SSH. So the username and password is SSH. Okay, so let's try that. From this, let's say we got to do this. So let's go ahead and just up. So from the command prompt establish, From the command prompt, establish an SSH session. Okay, okay, so we good. Okay. Now let's paste this. Hit enter. So it asks us for the password. So username is SSH admin command space it. It says login invalid. Or is it? So it asks us for password. So let's type in the password. Instead of typing in, let's just copy it and hit that and paste that. So we log into router 2, as you can tell. So it says when finished, exit the SSH session. So we got to exit the SSH session. So just to show you, this is PCA, and from this PC, as we were told, we log into the router 2. So to confirm that, let's just enable conf t and says do show IP LFSBR. And so there go all the tables that they go all the IPs that we just ping from PC from on router 2. So there we go here. So we good. Now let's just end this session. And then what are we told that we got to do just to X out? So it says that exit is what we use to exit out. So we back to the PC just to show you that we could do IP config and then, oh, sorry. So IP config. So we back to the PC. Okay, so now it says that on step 2, from PCC, verify connectivity to PCA and router 2 from PCC, which is this PC here. We have to grab the command. So from PCC, verify connectivity to PCA and router 2. So the IP address of PCC, for the IP address of PCA is as follows. This one here, 192.168.1.3. So let's copy it and let's come here and hit ping. And then we paste this. Okay, so we have a connection. So now what else it says? It says that we so now the IP, so these are the whole IP here that we gotta grab for router 2. So let's see, and we got a ping. Now let's grab the second IP address from /001 serial NFS. That's what that means. So we would do an up arrow, and then we will move as we will move what to remove. And so we back, we hit that, so we get a ping again. So let's grab the other IP. Then we would have the loopback IP to ping. So let's do up arrow and remove this IP address. Let's just paste this one here. So we get a ping. So now we grab the last IP, which is the loopback IP. Let's grab it. Okay. So let's just do an up arrow and we move the IP and then put this IP. Okay. So now we have pretty much done from this part that says from PCC, verify the connectivity to PCA and router 2. So we have done that. It says from the command prompt ping PC, from the command prompt ping PC, PCA, which we already done. So it says from the command prompt establish an SSH session to router 2 with the loopback address. Okay, so we get that. All we got to do is just do this. Let's grab this, copy it. If you follow me, you could do that. Now the loopback address, which is not this address, and that's why I was copying just this. So the loopback address, where was it? So it's this address here. No, it's the same address, wasn't it? 192.168.2.1. So it's the same address. Why don't we go ahead and just grab the whole thing? I thought it was a different address. Oh. So basically, when I'm doing this lab, we're doing it together. It's not like I did it before, and then I come and teach you this. Okay, so now we got to type in the username, what we have. Oh no, the password. So the password was this password here. Let's just grab it. Copy. Let's hit that and paste this and hit enter. So we log into the router. So we could do conf t and then do show IP and BR. So there we go, all the IPs that we've been pinging. So we good. So it says that, yep, so we have that here. So we'll just close the session for that. So when we close that, we got to do what? Exit to close it, exit. So back to this PCC. So now it says that open a web browser from PCS server, and then so open a web browser to the PCA server 192.168.1.3 to display the web page. Close the browser when done. So from PCA, let's go ahead. We got to open a web browser. Let's close this. We open a web browser and then we type in which IP address. Let's see this IP here. Okay, so it's frozen a little bit. We got to give it some time. So hopefully we don't have to start all over again. Okay, so what do we got? It says that we got to ping this IP here to log into some sort of web server. So let's paste and hit go. So there we go. We log into the web server. Welcome to the packet tracer, bang, bang. Okay, so we log into this and then it says to display the web page and then close that when done. So that's all that we had to do. Now, in this section, it says secure access to routers. So configure ACL10 to block all remote access to the router VTY lines except from PCC. So use the access list command to create a number IP ACL on router 1, 2, and 3. So it's not being provided. We got to type this ourselves. So just a second, please. Okay, guys, so we have to start typing and make this configuration ourselves. So, it's always a pain, but you know, you gotta do what you gotta do. So let's go ahead and just start making configuration. So it says, first and foremost, it says that secure access. So on port 2, we have to secure access to the routers, which means that all of the routers have to be secured. So it says configure ACL10 to block all remote access to the routers, VTY line, except from PCC. So let's grab this. Okay, so that's router 1. Let's hit enter. Oh, oh, I forget. We gotta type in the password. So to get it to the enable mode, we gotta hit this and then hit that. Huh. That's what I don't like about this. So we gotta type it in. I wonder if that's this password. I mean, maybe it's this one. So okay, that. So hit this. Okay, so we gotta put it in enable mode, and then we grab this one. So we know that was just the wrong password we've been using. Okay, so we in. Now we could say conf t. So first thing first, we out. So we've been right there. So we gotta do access list 10 and then permit host. So which host that we've done? Let's check. So uses as the incoming traffic. So the host have to be this router because this says that we have to permit only PCC. So let's go ahead and see where we are. So it says that, okay. So it says that we have to use the command list. Okay, it says to configure ACL to block, ACL 10 to block all remote access to the router VTY line except from PCC. So we gotta give access to only PCC. Block all remote access to the router's line except from PCC. Okay, so now what we have to do, is to apply ACL 10 to ingress traffic. So ingress means the incoming traffic, and the egress means the traffic that's leaving. So it says that apply the ACL 10 to ingress traffic on the VTY line. So use the access class command to apply the access list to the incoming. So that's what. So the incoming traffic, that's what's the ingress mean, the incoming traffic on the VTY lines. So let's go ahead and do line VTY and then 0 to 4. Now we say access class 10 in. Now we got to do access class. Oh, sorry, access class. No, access list. Access list 120 permit. Oh, sorry, permit. Am I in? I think this got to do on the configuration mode, but let's try it. Permit UDP any host 192.168.1.3 .1.3, and then we could do EQ domain. So it did a ticket. So we got to do, let's copy this. So this got to be done on the configuration mode. So conf t, then see if we can paste this whole command. Oh man, it doesn't take it. So what can we do? See if we can copy it. Okay, so we can copy it here. Then move this and paste it here. It's got to be done on the. Is it not taking this? Oh, on the access list. That's my mistake. That's my mistake. Hold up. So this should be done on the configuration mode. Water one. So let's do access list. 120 access list 120 permit UDP any host square bit at 3.1, so which is PCA, paste it, then we do EQ, and then domain, so enter. So I take it now. Now let's just do an all-power to block the SNMP for the SNMP on PCA. So let's do EQ EQ dash SNMP SNMP. So we have access list 120 permit, but it's from the TCP because SNMP is a TCP. So it's TCP. So TCP, thought this will give it to us by the tab, but it's not. So TCP. Okay. Okay. Are we good? We're not. What do we do? So it gotta be access list 120 permit TCP any host 192.168.1.3 and EQ. So I'm taking this. 1.3. So TCP and any host 192.168. Okay, let's type it. So access list 120, and then permit TCP any host, then type in the IP address, then we could do EQ. Does it take the EQ? EQ, EQ, SM. Oh, so it's SMTP. It's not SNMP. I'm sorry. So it was my bad. Okay, so we good. Now, let's do an all power and do access list 120 permit TCP any host of 192.168.1.3 EQ FTP. FTP. Okay, enter. And now let's do an EQ for HTTPS. So it's for 443. And now we gotta do a host EQ for SSH. So let's do an opt-out to remove this EQ. So let's say so let's do we gotta change the IP now for PC3. Let's do host and then grab this IP address. So it's a 10.1.1.1, which is the serial. So serial router 1. Then now we could do the EQ, and then port 22. What's invalid? Let's do an power. So access this 120, permit TCP, TCP host. Okay, my bad. So it's TCP host. Right. So we're good now. Now, we have to apply the ACL to the NFS, serial NFS 0/0/0. So let's see here. So verify exclusive access for management station to PCC. Yeah, but we gotta finish first, so we gotta finish. Okay, so now we gotta do NFS serial 0.0.0 and then IP access group 120 in. Okay, so now we gotta verify that PCC cannot access PCA via HTTPS using the web browser. So from PCC, so verify the exclusive access from the management station PCA. So we here, we've done this. We create an IP ACL number 120 with the following rule, and we permit any outside host to access the DNS, the SMTP, and the FTP service on server PCA. We deny any outside host access to HTTPS services on the PC. On PCA, we permit PCC to access the router via HTTPS. So it says check the result will not show a correct configuration on ACL 120 until you modified in port 4. So it says now verify that PCC can access the PCA via HTTPS using the web browser. So let's try that. So say PCC. Let's close this. Use a web browser. For that, PCC can access PCA. So let's grab the IP address of PCC. What protocol do we have to use? HTTPS. Where we at? Okay, verify that PCC can access. So, but be sure that disable HTTP and enable HTTPS on PCC, PCA. So let's hit this and hit that. So right, it says that be sure to disable. So yeah. So PCC cannot access PCA via HTTPS. Let's try it. So PCC cannot access PCA. So let's grab PC. Yep, PCC cannot access PCA. Okay. So now we have to modify an existing ACL on router 1. So configure ACL 120 to specify permit and deny the specific traffic. The specified traffic, use the access list command to create a number IP ACL with number 120. So from router 1, let's go ahead and exit out 1. Exit out 1. So we have to do access list 120. And then we say permit ICMP any echo reply. Let's give it to us echo reply. Okay. So that's what we do here. Where we are. Okay, so yeah. So now we're going to apply the ACL to the NFS. So I have done that already. Yeah, I've done this step already. Yeah, so that's where we are. So modified an existing ACL on router 1. So we got to permit the ICMP echo reply and destination unreachable message from the outside network relative to router 1 denying all other incoming ICMP packets. So we got to verify that PCA cannot successfully ping the loopback interface on router 2. So PCA cannot successfully ping the loopback interface on router 2. So let's try that. Loopback interface, that's on router 2. Is this IP here? Let's go ahead. Which PC that can ping it? Let's see. So verify that. So verify that PCA cannot successfully. So let's go on PCA. Command. Let's go on ping. Oh, yeah, the ping. So maybe it's when we finish. We'll try that. Let's give it some time. Let's pull up router 1 and finish all our configuration. So it says that after we done this. So it says that make any necessary change to ACL 120 to permit and deny the specified traffic. So use the access list command to append the required entries to ACL 120. So let's do all power. So we're gonna do access list 120 ICMP, any unreachable. So we should do that first before we even try to ping it. Unreachable. So then we could do an all power and do access list 120 denied. Now denied ICMP any. And then we should do an all power and do access list 120 permit IP any. Okay, so now let's pull up PCA. We at. So let's pull up PCA and try to ping the loopback address again and see if we get a successful ping. Because we should not be able to get a ping. So we still get it. So it says that it takes some time before it even take effect. So we're gonna get back to that later. Now, what else we doing? Let's check. So it says that verify that PCA can successfully ping the loopback address interface on router 2. So we got it. We just did that. Now it says to create a number of IPSCL 110 on router 3, deny all outbound packets with any source address outside the range of the internal IP addresses on router 3. So in step 1, we got to configure the ACL 110 to permit only traffic from the inside network ACL. This got to be done on router 3. So let's go ahead and pull up router 3. So, forget. This is not. Then enable, and you got to put the password for that too. This is a pretty interesting lab. Is it paste? Okay. Okay, so we do conf t. Now, let's go ahead on router 3. We could do access list 110. So we've been told. So here's what we're doing. Port 5. 110 permit IP, and the IP address is 192.168.3, this network.0, and the loopback, the subnet mask is .0.0.0.255. Then we say any. Now, we got to apply the ACL to the interface gigabit 01. Just this steps here. So let's go ahead and say add gig /01 IP group, IP access group, IP access group 110, that's what we've been told, and in. So now in part 6, we have to create a number of IP ACL 110 on router 3. So let's go ahead and do that. This is pretty much gonna be just like the one that we did for the on water one. So that's it. So we gotta do the access list 100 permit. So that's what it says. IP access list 100 permit TCP. Now that's gonna be the IP of the router. 1.1.1. That's 0. Okay. So now we get that 0 and 255.255.255. Why does it say the command is in? Okay, so I forget. We gotta put the EQ and then twin host. Now the host should be this IP, which is that 3. Okay. Okay. So now we gotta block all the other ones. So we allow only PCC on the 100 access list, and now we gotta deny. Oh, gotta do access list deny. Oh, the access list number. It's too quick. Deny IP. So if you could grab this. Copy, paste it, and then do any. Now let's up our hole and grab for the IP. One seven two dot 172.16.0.0, and then we get what 0.15. Okay. Okay, so now then we have to deny another one again, another network, which is 192.168.0.0, and then the subnet mask, you already know. So one more denied from this network, 127.0.0.0. Okay, all that. Already noted mask. So it's 255. Okay, where do I go on? Extra zeros. Okay, where do I go on again? So access list 109 IP. was used. So we good. Now we gotta deny a last network. We gotta deny the last network IP 224.0.0.0, and the subnet mask is 15.255.255.255.255 and any. So now we got to access and permit on 10, permit any, permit IP, any, oh, sorry, any. Okay, so now on step 2, we should apply the ACL to the interface of serial. Let's try. So we should apply the ACL to the interface serial 001. So that you're gonna say interface serial 0/0/0/1. Then we gotta do what? IP IP access group 110, no 100 and in. Okay, so it says that you gotta use the IP access group command to establish the access list to the incoming traffic on the interface serial. Bang, bang, bang. So then now it says that we have to confirm that the specified traffic entering interface serial 001 is handled correctly from PCC command. Bang PCA, CCNP will go reply or block in any ACL. But then we gotta do on router 2, we have to do a slight thing. Router 2, let's go ahead and log in before we do that. So let's go log in. Set. Then EN, then type in this IP. Then we do conf T. In router 2, we have to do the access list 10 permit host of 192. Which host? Let's just go ahead and grab it. It's only host. That's what we've been told. Right? So accessed 10 in. So it's, sorry, access class. What am I doing? Oh, that's my mistake. So let's do this. So then we have to do the line VTY 024. Then we should do access class 10 in. Very good. Okay. So now what have we been told? It says that to confirm that the specified traffic entering interface serial 001 is handled correctly. So from the PCC command prompt. So from PCC command prompt, do we do ping PCA, PCC command prompt, so says ping, then PCA. So what does it says? Ping PCA, the ICMP echo reply or blocked by the ACL. So we good. It says because they are source from 192.168.0.0/16 address space. So it says establish an SSH session to 192.168.2.1 from PCC. It should fail. So let's try that. So let's try. So SSH to which IP? Let's try this. So what is it says? On PCC, it should fail. It says establish an SSH. Establish an SSH to this IP. It should be successful. So it's failed. Now this IP belongs to what? Let's see. To the gigabit Ethernet 0.0. So let's do this. It's a pretty long lab. So it says it should be successful, and it is. Access for the username and the password is this. So we see we get it. So add conf t typo, but we do. So we have done everything. Check the result. The completion percentage is 100%. So click check. We're done. We're done. So yes, so we have done everything. All right, guys. So thank you so very much for following along with me. I appreciate you was here. So stay tuned for another video lab session on the CCNP Encor exam. So I'm looking forward to connecting with you in the next lab lecture and configuration. So thank you. Bye-bye.